Hello students, this is lesson U1A08. Hopefully by the end of the lesson you should be able to say I can solve problems involving angle relationships between parallel lines cut by a transversal and sum of angles in a triangle. I am so excited about this lesson because we are building our repertoire of different tools and skills. We're developing and harnessing our ability to communicate and growing our vocabulary in geometry. So this is one of those culminating lessons that I think should help everyone make all the different connections. So rather than looking at different skill sets in isolation, this particular lesson requires you to gather all the different skill sets that we've acquired over the course of the 17, 20 lessons or so, and bring it all together. So let's just take a look at this. All right, so I'm not going to go through this in a formal proof approach, just because I feel like maybe perhaps the language ideas gets lost in the translation. So I'm just going to I'm going to ask everyone to think about this logically, okay? And the objective here, okay, is to show that angle B, F, and C, so these three angles, add up to 180. Okay, some of you may have enrolled into this class already having this understanding that the sum of the angles in a triangle is 180. But in this problem here, we're going to show why that's the case. And so I'm going to ask you to direct your attention not only to those three angles, but also to the fact that this is a triangle. Okay, so this triangle is inscribed in between the two parallel lines, L1 and L2. All right, so now that we have all these, and the only thing that's actually given in the problem is the fact that the two lines here, L1 and L2, are parallel. That's the only fact. So having this understanding, okay, let's try to go through this and formulate our understanding together, okay? So right now, we have this understanding that angles E, F, and G all are supplementary. E, F, and G all add up to 180. And if you're wondering why, well, that's because E, F, and G are they're not quite a pair; they're a trio. Okay, but we classify them as a linear pair. It's the same kind of situation. All three angles add up to 180 because all three angles form a straight line. Okay, if ever you have angles coming together and they form a straight line, we refer to them as a linear pair, or in this case, a linear trio. Okay, so with that understanding, okay, angle E has one tick mark, angle F has two, and angle G should have three, okay, because it is not a requirement that any of those angles are the same. But what we do know, having gone through the all the different lessons, okay, in the past series, in the past sequence of lessons, right, I recognize that angle E and angle B are going to be congruent because they are alternate interior angles. I also recognize that angle G is going to be congruent to angle C for the same exact reason that they are alternate interior angles. So upon inspection now, recognizing that E, F, and G add up to 180, but wait a minute, E is also congruent to B, is it not? F is congruent to itself, and G is congruent to C. So therefore, we can proclaim that all the angles inside of a triangle will indeed add up to 180. So there you have it, okay? The sum of all the angles inside of a triangle is in fact 180. Okay. So I'm going to fast forward this is the formal proof. If you want to take a look at this a little more closely later on, okay, please do that. Pause the screen and read it. Okay, so this is the summary right here. So the sum of angles in a triangle is 180 degrees. And we are going to capitalize on this fact because now we have another theorem to play around with. Okay, so we moved away from a postulate, and now we have our first theorem. All right, so let's take a look at this. The goal here is to solve for all the missing angles. So again, recognizing, okay, that these two angles are linear pairs. Or actually, pause the video, see if you can figure this out on your own, okay, and then come back. So hopefully you had some opportunity to try this out. Those two angles that I circled there are linear pairs. So immediately recognizing that 3x plus 6 and 2x plus 4, they should add up to 180, of course. So combining like terms, I recognize that this turns into 5x plus 10 is equal to 180, or 5x is equal to 170, or finally x is equal to, what is this, 32. Is that the case? No, 34 is equal to 34. So if x is equal to 34, and the goal is to figure out all the different angles here, right? So immediately I can see that this is going to be, let's see, 34 times 3, that's 102, plus 6, this is 108. And being that those are supplementary, this must be 72. And this is 34. And finally, because all three angles inside of a triangle must add up to 180, then I will have, what will this turn out to be? This will turn out to be 74. Right? Because 74 plus 72 is 146. 146 plus 34 is, in fact, 180. Okay. Let's take a look at our next. Here is another theorem, okay, that we can capitalize from the sum of angles inside of a triangle is 180 degrees. So let's just take a look at this, okay? So right now I have x, w, y, and z, right? So what am I trying to capitalize on? I know that y plus z must equal to 180 because those two angles are linear pairs. I also recognize that w plus x plus y is equal to 180 degrees because the sum of the angles inside of a triangle is 180 degrees. So recognizing this, okay, I immediately see that y plus z is equal to w plus x plus y. And doing just a little bit of simplification here, I subtract both sides by y, I'll end up with z is equal to w plus x. Or in other words, this angle over here, which is outside of the triangle, this is an exterior angle. This exterior angle is going to equal to the sum of which two angles? The two interior angles. The two interior angles that are not adjacent to the exterior one. So those two angles will add to that exterior angle. This is the exterior angle theorem. All right, so we're going to try to capitalize on this. So immediately I see here that this is an exterior angle, and then the two interior angles that are not adjacent to 130 here, that is not adjacent to the exterior angle, are these two guys. So immediately I recognize, well, what do you recognize? Pause the video, see if you can apply the theorem. Okay? Immediately I recognize that the exterior angle 130 is equal to the sum of the two interior angles, x plus 10. The goal here is to find out what angles A and B are, so I'm going to solve for x first. I end up with 2x plus 10 is equal to 130, or 2x is equal to 120, or finally x is equal to 60. So if x is equal to 60, then angle A is 60 degrees, and angle B is 70 degrees. And that's it.